Lesson number 23, daily summary. In this lesson, we learn how to use the quadratic formula to solve quadratic equations. Number 1, graph A represents the parabola for the quadratic equation y equals x squared plus 5x minus 6. Looking over at the graph, hopefully we can identify or estimate the x-intercepts. It's kind of hard to tell on my version of this, but on your printout it should look better. But I think the x-intercepts look like they are happening at x equals 1 and x equals negative 6. It's written here. Again, y is 0 in both cases. So then it says use the graph to identify the solutions to the equation 0 equals x squared plus 5x minus 6. Well, take a look at the two equations we've got up in front of us. The right-hand side is exactly the same. The left-hand side is different. So the only change between these two equations is that the y has become a 0. And so in order to solve this equation, we know that we are looking for points where the y is equal to 0. Well, let's take a look at the graph. Points where the y is equal to 0 are exactly the x-intercepts, right? Like at those two x-intercepts, the y is 0. Every place on the x-axis, the y is 0. So if we're looking to solve this equation, this 0 equals equation, we can just look at the graph and find the two x-intercepts. So our answers are the x values of the x-intercepts. Negative 6 for x, 1 for x. Those are the solutions. So I guess the connection here we're looking to make is that x-intercepts of a graph correspond to solving the original equation equal to 0. Right? Like this whole equation, this whole expression right here, make it equal to 0. That corresponds to x-intercepts. But suppose that we weren't fortunate enough to have that graph in front of us like we were here. Could we still solve this equation using algebra without the graph? Sure, we can solve this equation by factoring. So I'm not going to go into the details, but if you do the 2x2 box method, you will factor the right-hand side as follows. You will get x, what do we get here? X plus 6 and x minus 1. So feel free to pause the video here and do the factorization with the 2x2 box if you wish. But I'm going to move on and solve the two simpler equations now. 0 equals x plus 6, or 0 equals x minus 1. And so then subtract 6 from both sides, add 1 to both sides, and we get x equals 1 and x equals negative 6. No surprise, those are exactly the right answers because we read them off of the graph when we saw the x-intercepts. Okay, all well and good. Take a look at graph C here. It says the parabola that we're looking at is the graph of y equals x squared plus 2x minus 5. So let's go ahead and estimate the x-intercepts. This one's a little bit tougher. It doesn't, I don't know, like negative 3.5, but not really. It looks to the right of negative 3.5, and that other point looks like it's a little left of 1.5. So how about we call it negative 3.4, comma 0 and 1.4, comma 0, but it's really hard to know. And then what if we wanted to solve this, well, let's do this part. Use the graph, identify the solutions to the equation 0 equals x squared plus 2x minus 5. Well, the solutions are x is roughly 3.4 and x is roughly 1.4. But if we wanted to try to solve the equation without looking at the graph, we want to try to factor this equation. Well, I know I got to put an x and an x, and then the only way to build that minus 5 is either with a plus 5 and a minus 1, or with a minus 5 and a plus 1. And it turns out that neither of those options is going to give us that plus 2x in the middle. You could try foiling both of them out. You will not get the positive 2x that you need in the middle. You could do the 2x2 box method, and when you get to the part where you're looking for two things that have a product of negative 5x squared and a sum of 2x, you will discover that such things do not exist. And so this one doesn't factor, but still there are answers, right? Like the equation has two answers, roughly negative 3.4 and 1.4. So how do we get those two answers if we can't factor? Well, we need a new tool, and that new tool is called the quadratic formula. So here it is. I suspect many of you have seen this in a previous math class, but I want to let you know that the quadratic formula, while it is, you know, like a lot of folks just have this thing memorized, so I'll point out that this is an equation. It is x equals that whole big mess, and also that it comes from some other stuff. The quadratic formula, I guess technically is just that, but you need the other parts of this theorem for the quadratic formula to have any meaning. So here's the full statement of this theorem. A quadratic equation written in the form ax squared plus bx plus c equals 0 has the solutions x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So we're going to see that in play. We'll do two big examples with this quadratic formula in the demo here. But first, I'll point out that the plus or minus symbol used in the quadratic formula combines two equations into one. It means that the solutions to that equation right there are x equals. So here's the whole thing, but instead of the plus or minus, I've just written the plus here. And then there's the whole thing again, but now I've just written the minus there. And so this plus or minus formula is really saying two different things, but we just compress them into one instead of listing them all the way out with the plus and the minus separate from each other. So 5 says memorize the quadratic formula soon. Ask your teacher. They might be willing to put the quadratic formula on the test or quiz where it's tested. If you go on YouTube, you can find some people singing the quadratic formula to the well-known tune Pop Goes the Weasel. Let's go ahead and try number 6 here, where we'll use the quadratic formula to solve 5 equals x squared plus 2x. Let's give it a shot. So first of all, we need to identify the values of a and b and c. Okay, so a is always the number touching x squared. In this case, it's invisible. It's a 1. So a is positive 1. B is always the number touching x. And that's right here. Oh, I should have circled the sign as well. That's positive 2. And then c is the number not touching any x's, which at the moment feels like it is this one, 5. But I will tell you, if you use the quadratic formula on those 3 numbers, you will not get the right answer because we made a mistake here. As I said, the quadratic formula isn't just that formula. It solves a particular equation, and the format of that equation is crucial in applying the quadratic formula. In order to use the quadratic formula, we need an equation where one side is 0. And so this equation is not in the right form. We first need to subtract 5 from both sides. That's going to get us a 0. So really, down here is the equation that's in the right form. It's in the quadratic formula-able form. So now we can read A, B, and C. A is still 1, that was correct. B is still 2, that was correct. But C is negative 5. Really important to get that negative symbol there. Okay, so now we'll do the quadratic formula. This is written out below here, so I guess we're just going to kind of point. Let me copy those values. Oh, actually, they're written right up here. I don't need to copy them, but there's the A, B, and C we just established. So here's the quadratic formula written all the way out. Again, notice it starts x equals. It's really important you understand these are x values that you are finding. And I will say that it is my practice when I use the quadratic formula to write the entire formula out, and then the very next step I write the same formula out, but I put blank parentheses for every single letter, A, B, or C. Every one of them becomes blank parentheses waiting to receive the correct value of A, B, or C. And so you can see here, I've overdone it in terms of parentheses. I didn't need that many, but I think it's good practice. I think it reduces the chance of error. A lot of folks have issues with signs, you know, pluses and minuses when they're doing this complicated formula. I think putting everything in parentheses minimizes the sign issues that might come up. So we've just plugged in, instead of B, we've got a 2. That's right here, but the negative sign is part of the formula and it's copied down. I see a plus or minus there. I see a big square root. B squared, that's really 2 squared, that's here. 4 times A times C. 4 times 1 times negative 5. And then don't forget it's a subtraction inside here. And then the bottom is supposed to be 2a, so that's 2 times 1. Okay, and then from this point forward, every step is supposed to make our expression cleaner, simpler. So let's go. Next task is to get rid of all those parentheses that we were so careful about including. So negative in the front of 2, that's just negative 2. 2 squared, that's positive 4. And now let's be really careful here. My recommendation is that you treat all 3 of these numbers as being positive numbers. Positive 4, positive 1, positive 5. I'm ignoring the subtraction sign in front of the 4, and I'm ignoring the negative sign in front of the 5. But I'm just doing 4 times 1 times 5. And that I cannot get wrong. It is positive 20. In fact, it's always positive the way that I do it because I ignored the negative signs. So I would put 20 right here, and then I would pay attention to the signs that I ignored. In this case, I ignored a subtraction sign and a negative sign. And I'm treating them both as negatives in my mind. And when I multiply two negatives together, I get a positive. And so those two negatives smush together to this positive. So I write 20, and then I think about how many negative signs I have. And that tells me whether I should put a plus or a minus. Okay, let's keep going. 4 plus 20 inside that radical, that's easy, that's 24. And oftentimes this is the end, this is the final answer for a quadratic formula problem. But in this case, we can simplify, and we have to simplify if we can. And we talked about these kinds of problems a few classes back. Our first step, most important step, was to split into two fractions. So -2/2 right here, and then plus or minus in the middle, and then radical 24/2 is right there. And then we can separate and simplify these fractions independently of each other. So -2/2 is -1. And then square root of 24, that actually is written down here. So the square root of 24, well, let's see, 24 is not a perfect square, but it does have a perfect square that goes into it. 24 is really 4 times 6, and 4 is a great number inside of a radical. Notice that we're not writing 24 as 8 times 3. We're intentionally picking a perfect square factor of 24. Then we know that we can split a radical of a product into the product of the two radicals. And then the square root of 4 is just plain old 2, no more radical, but that 6 has nowhere to go, so it stays right inside the radical. And so square root of 24 is really 2 radical 6. Square root of 24 became 2 radical 6. And then finally, you can reduce the 2's. In this case, they just plain cancel. So our simplified answer, -1 plus or minus radical 6. Again, these are values of x. Two different values of x. Two solutions to this original equation right there. Okay, in addition to wanting you to be able to write the solutions out in exact form, which is what we have here, and again, just remember that means that our two answers are really -1 plus root 6 and -1 minus root 6. That's the plus or minus, just kind of listing them both separately. In addition to the exact solutions, I also want you to be able to get decimal approximations. So let's do that now. I'm going to go ahead and do this on this calculator here. I encourage you to try to practice these problems on whatever calculator you're actually going to be using on any upcoming quizzes or tests or final exam, because these are the most complicated things we're typing into the calculator all semester, and it's really easy to not quite push the buttons in the right order, and there's no need to train yourself on a calculator that isn't going to be the one you'll be using on test situations. So you could just type in -1 plus radical 6, and that will give us one of our answers. Whoopsies, -1 plus radical 6. And that gives us one of our answers. Or you could do -1 minus radical 6. That's going to be the other answer. And so we have our two, oh, what am I doing here? -1 minus radical 6. So that's our other answer. So we get our two decimal approximations. Let's call it 1.45 and -3.45. So those are our two approximate answers. But typically the quadratic equation things don't simplify as much as they did here. So I want us to be able to type them in their more complicated typical form, which is this. So I'm going to type it in, and just like this, and I'm going to make a very common mistake, and hopefully you can catch me. -2 plus the square root of 24. Close that parentheses for the square root of 24, and that's the whole numerator, and then I divide by 2. Now I'm going to hit equals here, and we're not going to get one of the right answers. We already saw the right answers. Was -3.449 and 1.449, not this. So hopefully you see what I did. The mistake that I made is that I didn't put parentheses around the entire numerator. So what I should have done is open parentheses, -2 plus square root of 24, close the radical, close the numerator, and then divided by 2. This will give us one of our answers. And the other answer is exactly the same thing, but we'll just change the plus here to a subtract. Okay, so those are the two answers, but it's so easy to make this mistake that I made up here at the top that I'm going to make a different recommendation that you not even type it in the way that I just typed it in. My recommendation is that you do the numerator in one step by itself. So here's just the numerator with no parentheses needed to, we don't need to remember to put parentheses around the whole numerator. We're just doing the numerator just like that. Don't even need to close the parentheses for the radical. I just hit enter. That's the numerator. How do I get my final answer? I just divide by 2. And when I hit the divide key, the calculator is smart enough to know I mean the previous answer divided by 2. So 1.449, that's one of our answers. And then the other one is this guy. So again, just the numerator by itself. Hit enter right here, and then divide by 2, and that gets us our other answer. So make sure that you practice typing these things into your calculator. That's part of what we're after, is making it so that we can correctly type these into the calculator. All right, so number 7 says this one has fractions, so let's try it. It's negative 2x squared minus 7/3 x equals negative 1. You are welcome to use the quadratic formula on any quadratic equation, including those with fraction values touching the x's. But if you don't want to do that, you are welcome to clear all of those denominators by multiplying both sides by the lowest common denominator. So check this out. We're going to multiply both sides of this equation by 3, because the only denominator I see is 3. And when I multiply the right-hand side by 3, I get negative 3. That is right here. And then the 3 on the left-hand side distributes. So let's carefully distribute. So 3 times negative 2x squared, that's negative 6x squared, right there. And then we do this 3 times the negative 7/3 x. Now don't even bother doing 3 times 7 to get 21. The whole point of putting this 3 here was to cancel with this 3 in the bottom. And so if I write up here the multiplication that we're doing, it's 3 times negative 7/3 x. And the 3's straight up cancel. The 3 is not even available to hit the 7 anymore. So there's no negative 21. You just cross off the 3's and you're left with negative 7x right there. And so that quadratic equation is a whole lot friendlier to me because it does not have fractions anymore, but it still has exactly the same solutions, the same values of x that the original did. So nothing lost, only something gained. We don't have to deal with those fractions. We are not yet ready to identify a, b, and c because we don't have a 0 on one side. So let's add that 3 to both sides to give us this equation. And so now we can identify a, b, and c. A is the number touching x squared, that's negative 6. B is the number touching x, that's negative 7. C is the number touching no x's, which is a positive 3. And now we will apply the quadratic formula. Again, it's x equals. It's not just the formula. It's x equals that formula. And then here I will put into practice what I said, which is to copy the entire thing, but every a, b, and c becomes open parentheses, waiting to be filled in with the right number. So every quadratic formula I do, I start with that skeleton, that empty shell. And now we'll plug our numbers in. So the first one was supposed to be negative b, so b is negative 7. We'll just plot that right there. The next thing I see is b squared, so that's again negative 7, but it's squared this time. Then it's supposed to be 4ac, negative 6, positive 3. We just fill them in, it's easy. And then on the bottom 2a, that's 2 times negative 6. Okay, let us keep calculating here. First part, now we're trying to get rid of all these parentheses we put in. Negative 7, that is positive 7, plus or minus, square root. Okay, be really careful here. Negative 7 squared, is that 49 or negative 49? It is 49. Negative 7 times negative 7 is positive 49. Okay, and now I'm going to ignore the minus sign and the negative sign, and I'm just going to do 4 times 6 times 3. That's 24 times 3, which is 72. And now I'm going to think about my signs. So I see a subtraction, and I see a negative, and that's 2 negative signs in my mind, and 2 negatives multiplied to get a positive. So that's 49 plus 72. All too often I see folks put 49 minus 72 because they don't quite keep track of the signs. All divided by 2 times negative 6, that's negative 12, equals 7 plus or minus, okay, 49 plus 72, that is 121. That is an interesting number to have inside of a radical. Again, oftentimes this is the end of the problem, but if you can simplify it, you must. And in this case, this one simplifies quite dramatically, actually, because the square root of 121 is an integer. It's 11. So let's put that 7 plus or minus 11 divided by negative 12. I noted that in the previous problem, we separated this into 2 fractions. But that's not what we're going to do here. In this case, we're separating it, but not over fractions. We're going to separate it over the plus and minus. So here's how we do that. X equals negative 7 plus 11 over negative 12, or X equals negative, I said negative 7. I should have just said 7 up here. 7 plus 11 over negative 12, or X equals 7 minus 11 over negative 12. So again, we're splitting into two, but not in the fraction way, not two fractions with the same denominator, but instead we split over the plus and the minus. We just write out the plus and the minus, and then we'll just simplify these fractions. 18 over negative 12 reduces to negative 3 over 2. That's one answer. 7 minus 4, that's 7 minus 11 is negative 4 over negative 12, which is 1/3. So those are our two answers, negative 3/2 and X equals 1/3. So lots of practice with the quadratic formula. It could be intimidating in the beginning, but it's really not so bad with some practice.